Well, this is a video for how to configure a scanner or some RS232 device to a micrologix 1100 or a micrologix 1400. So, for example, I just made a new project. I named it scanner. So, to start with this, I, for example, selected a micrologix 100 00. So you can change it or you can configure it here. It depends on what do you want to do or something like that. So first of all, channel configuration. For a micrologix 1400, you will have three channels. Channel 0 and channel 2 are used for serial communication, or the F1 full duplex. For example, here is configured for an RS232, so it is automatically configured as ASCII and for a baud rate of 9600. So once you have this configured, you need to use your ASCII functions. I always recommend to use the help instruction help, and this will show you all the ASCII instructions you need. For example, I will look here, ASCII instructions. So first of all, we are going to need an ASCII read line. This is used for the buffer. When you're using a serial device, you will have a buffer automatically in the system. So for example, here, as a good practice, I recommend you to use just the main ladder for the hot jump to subroutine. So for example, I will name it as main. And here I will use my scanner. So for example, I will need to add an ASCII read line. Here I have it. So it works in different ways. For example, you need to have a transition from true to false, from false to true, sorry, to be able to read it. Here we can select the channel because we have multiple channels because it's a micrologix 1400. So if you're using a micrologix 1100, you will need to use a different channel. But here we have channel 0 and channel 1, as we saw before, channel 0 and channel 2, sorry. Channel 2 can be configured as well for ASCII reading, but we have already the channel 0 configured like that, so we're going to use channel 0, and the destination will be, you need to have a string data file. As default, we have output data file, input data file, status data file, binary data file, timer data file, counter data file, control data file, integer data file, and float data file. We have multiple data files types. If you need another explanation, Tony, you can ask. But for now, we are only see the string data type. I will name it scanner. And the number of elements is important because if you are going to use multiple sources or multiple conversions or multiple readings at the time, I recommend you always to give it like 10 or 20 spaces. I will use 10 just for the example, and everything else we can let it as default. So the destination will be a string data file. So we're going to select an ST. Here we can select by press enter, and automatically will give us the next unused string. Okay, we can comment here. It's gonna read. And we need a control data type. We don't have, oh well, we have a control data type here. Always the default inputs are always size of 1. So we need another, we can, for example, reconfigure this one by properties, and the elements I will give it another 10 just if we need more in the future. This is important to consider some spare registers because we could need to use more in the future. So we are going to use the register data type or control data type, and it will give this automatically the next one. Control. And the string length, it will help you to use the control bits, the string length. I will explain you the next. For example, for you, Tony, you need to know how long is the string you're going to read with the scanner. For example, I used to read like 20 or 25 characters, so I will use this, and these two are read or characters. You don't need to modify them, they will be modified. So, well, I will use a condition. So, for example, here, when the string length is 25, you will activate the done bit. So, for example, you will need to add another one. You can use another conditions by the done bit. So, for example, here I will use the R6 point done. This is how you call this register. If we open this register, the register control, the R60, you can see here that you are using the read and the write option. So here, when you have the 25 characters in the string, the done bit will be automatically put in 1. So will be set 1. So when the bit is set 1, you, for example, you can use your logic as you need. For example, I always clear the buffer. So if I have already my string ready, I can now clear the buffer. As we can see here, we can clear the buffer by using this one. Let's see. Clears the ASCII buffer. So, for example, here, use the ASCII line clear or ASCII clear buffers to remove from the QE. Okay, so for example, if you have multiple ASCII reads or multiple ASCII writes, you will have a QE. So they will be executed one at a time. For example, you can have a really long string in your buffer at the ASCII read, and you can use multiple ASCII read line. So this will be clearing all the buffer one by one, but you can clear it all. I recommend you to always clear the buffer and use just one instruction at a time for ASCII read or for ASCII write. So, for example, if you are going to read, or if you already have read the buffer, so you can use an ASCII read, ASCII clear line. So we are using the channel 0, and we are going to clear the receive buffer. The receive and the transmit buffer are different, so you have to consider this because you can clear them but depending on what are you using, or if your scanner have some status characters that can be received by the serial, you need to consider that. You can clear them both at the time, or you can clear only the receive buffer. I used to, in the example I have sent you before, I just cleared the receive buffer. I have another one because sometimes you can receive one bit, for example, at the time. Well, this is important to know right now. For example, in channel 0, you will have the termination characters. These characters will be considered as the end of the line. So this character is the letter D, or in hexadecimal, in decimal, it will be the 13, the number 13. In ASCII, the 13 means the enter or the next line of end of line. And this one I don't remember, but I always recommend you to send a clear string with only the characters you're using. So when you get the 25 characters, you won't have any character left in the buffer, because it will be done and it will be set at the string here. These strings have a length of 82, I think, 82 characters. So you have to consider this. If you're reading a really long string from your scanner, for example, 150 characters at the time, you will need to use two ASCII read line, one after all, and then use them in a separate lines, separate strings. For example, there will be one ASCII read line uh, for the first 50 characters, and another ASCII read line for the next 50 characters. And you will need an ST9 and an ST1, for example. ST9.0 and ST9.1, and another data register, because every block here will need a different string characters. So another important command that you can use is the ASCII to integer. Let's see, this will be this one. Converts a string into an integer value, this one. This is important to know that you can overflow an integer data file. So you must be very careful, because you can, if you're converting some letters, you have to convert just two at a time. And if you're converting only numbers, you can convert up to 5 or 6 numbers at a time because of the conversion. So you will need a destination. For all of these data files, you will need to make a download to apply the changes. You cannot change the size, or you cannot add a data type when the PLC is running on it or in program. You need to do a download. So I recommend you to download or upload a backup of the program, and with the backup make the modifications, so you won't modify the current values in the PLC, and then make a download. If you need more help with this, I can help you by the inbox in the forum, or I will give you our page of the company, and my email if you need to have a more private conversation. So this will be all the explanation I can give you. I'm sorry for my English. I don't used to speak too much in English. So see you the next time.